In this chapter, we'll be going over pediatric medications. So the idea for this section is that when we're giving medications to children, we might have to adjust the dosage because a small and young child might handle medications in different ways than adults. And in fact, some medications that are for adults cannot even be prescribed for children. So we're going to be going over 5 formulas in this section that are going to help us calculate the appropriate medication to give to the child. And these formulas are going to be based on the age, the weight, and the body surface area of the child. The formulas based on the weight or surface area tend to be more accurate than those based on age, because age is not always going to be a good representation of the body size of the child. So we're going to go over 4 formulas here first, and then the 5th one in a little bit. So these are all pretty similar to each other. They're all taking a fraction of the manufacturer's suggested average adult dose. So we're basing all of these on the average adult dose from the manufacturer. So the first one here, we have Freud's rule. And this rule is used for children that are just born to 24 months of age or 2 years of age. So the formula here is the child's dose is going to be the age in months divided by 150 months times the average adult dose. The next one is Young's rule. Young's rule is used for children from 1 year to 12 years of age. And this formula says that the child's dose is going to equal the age in years divided by the age in years plus 12 times the adult dose. And next is Clark's rule. Clark's rule is going to be used for all ages of children. And this is the child's dose is going to equal the weight in pounds divided by 150 pounds times the adult dose. And lastly, we have the surface area rule, which once again is used for all ages of children. This is going to be the child's dose is equal to the surface area in meters squared divided by 1.7 meters squared times the adult dose. Okay, so a couple observations here based on those formulas. If you notice that the Freud's rule and Young's rule ages overlap, so going up here real quick, Freud's rule, the formula went from birth to 2 years old. Young's rule went from 1 year to 12 years old. So there was an overlap from 1 year to 2 years. So when we're doing a question with these, we can use either one of these rules for children from 1 year old to 2 years old. But for the sake of doing the questions in this chapter, if the age in the question is given in months, we're going to use Freud's rule. If it's given in years, we'll use Young's rule. So that's for the overlap between 1 and 2 years. If it's in months, we'll use Freud's rule. If it's in years, we'll use Young's rule. And the second observation, we're going to be given the surface area of the child in the question, so we're not going to have to use any sort of charts to figure it out. But something called a nomogram is going to help us, can be used to help determine the surface area of a child. So for example, it's right here shown below. Let me zoom out a little bit. As you can see, we have 3 columns. We have the height on the left, the body surface area in the middle, and the weight on the right. So what you do is you go to the patient's height, and let's say that they were 59 inches tall. So you put a little marking right there. And then let's also say that they weighed 110 pounds. So you put a marking right there for 110 pounds. What you do is to estimate the body surface area, you're going to draw a straight line between those 2 points. And wherever it's intersecting on this middle column for body surface area, which would be right here, about 1.5, that would be the estimated body surface area. So it would be an estimated 1.5 meters squared for this example. Okay, so for finishing up these observations, so as we mentioned a couple times, surface area is going to be measured in square meters. That doesn't mean we're going to be squaring any numbers. and plugging in the number squared into the calculator or doing it by hand. The squared is just going to be a unit on the meters, and this is because we're talking about an area. Anytime we're talking about area, it's units squared. And the last thing here, pediatric medications are going to be usually rounded to the nearest tenth. So before we get into some examples, let's go over the steps that we're going to be doing when doing these examples. First step is identify which rule should be used, and then you can just write that down. Second step, substitute the given information into the formula. Third step is going to be evaluate. So when you're evaluating this, we kind of have two options how to do it. You can either multiply and then divide all in one big step, or you can put parentheses around the fraction that you're dividing and then multiply by the number, which in this case is the adult dose on the right. So after we get a number here, we're going to round to the nearest tenth, and we have to make sure, as usual, to label the result with the same unit as the given adult dose in the question. Okay, so let's do a couple examples. We want to find the dosage of Nembutal an 8-month-old boy should receive if the average adult dose is 100 milligrams. So first we're going to figure out what formula we're going to be using. The age that we're dealing with is an 8-month-old boy. So if we scroll back up here to the formulas to see which one we need, we're going to be using Freud's rule because that is used for from birth to 24 months of age. So that's going to be Freud's rule, so we can go ahead and write that down. So we have, for Freud's rule, child's dose is going to equal the age of the child in months divided by 150 months times the adult dose. So the child is 8 months old, and that's going to be divided by 150 months, and that will be times the adult dose of 100 milligrams. So notice that the months cancel, months divided by months will cancel, and once again, when typing this in the calculator, or doing this by hand, I guess, but typing in the calculator, you do 8 times 100 divided by 150, or you could do 8 divided by 150 in parentheses, and then multiply that by the 100, however you want to do it. Either way, you should get the same answer. You should get about 5.3 repeating, and then we have to remember to round this to the nearest tenth. So 5.3 repeating to the nearest tenth would be 5.3. And once again, we have to make sure that we label this with the correct units. It's going to be 5.3 milligrams. Okay, so that's the 8-month-old boy's dose for this medication. And let's do another one. So we have the average adult dose of aspirin is 10 grains. We want to know how many grains should be given to a child with a body surface area of 0.83 meters squared. So this time we're not given an age, but we're given the surface area, the body surface area. So that means we're going to be using the surface area rule here. So let's write that down. So the surface area rule says the child's dose is going to be the surface area of the child in meters squared divided by 1.7 meters squared times the adult dose. So the surface area in meters squared is going to be 0.83, and we divide that by 1.7 meters squared and multiply that by the adult dose given to us of 10 grains, and notice that the meters squared cancel off, so it's going to be 0.83 times 10 divided by 1.7, or once again you can throw parentheses around the division and then multiply. When we're multiplying this, we're going to end up getting 4.8823529. It's a long decimal. We have to round it to the nearest tenth, so we get 4.9 grains. Let's do 2 more examples of this. So the average adult dose of Demerol is 50 milligrams to 100 milligrams. We want to find the minimum and maximum a 30-pound child should receive. So we're not given an age here, so let's go up to the formulas to see which one we have to use. We're given a weight. So we're clearly not using Freud's rule because that's age in months. We're clearly not using Young's rule because that's age in years. We're going to be using Clark's rule because this is the one that deals with weights, and it's used for all ages of children. So using Clark's rule here, let's write that down. And the way I just set this up is we are doing it a little bit differently than we just did the other ones. We have a minimum value that we need and a maximum. So I'm going to have two different formulas, one for each of them. And I just abbreviated child's dose and adult's dose, CD and AD, just to save some space. So let's take a look at the minimum formula here that we need. So we have the weight in pounds divided by 150 pounds times the adult dose. So the child is 30 pounds, so it's going to be 30 pounds divided by 150 pounds times 50 milligrams. So this is the minimum, so that's why we use the smaller number for the adult's dose for this one. So when we are multiplying this, we see that the pounds cancel, and then we have 30 times 50 divided by 150. That ends up giving us 10 milligrams. So 10 milligrams for the child of 30 pounds is the minimum value. And let's see what the maximum will be. And this one's going to be using 100 milligrams. So it's going to be the weight in pounds. So once again, 30 pounds divided by 150 pounds times the maximum value of 100 milligrams. And evaluating this out, we're going to end up getting 20 milligrams. Okay, so those are our two answers for that example. Let's do one more here. For example, the average adult dose of Zynamax is 250 milligrams, and we want to know how much Zynamax should a 3-year-old child receive. So this time we're given an age, 3-year-old child. So if we scroll up real quick to the formulas, 3-year-old child, that is either going to be Freud's rule or Young's rule, because those are the ones that are dealing with age. And this one's going to be Young's rule, because 3 years old is in the interval 1 year to 12 years. So we're going to be using Young's rule, so let's write that down. The child's dose is going to be the age in years that's given divided by the age plus 12 times the adult dose. So the age in years is going to be 3 years divided by 3 years plus 12 times the adult dose of 250 milligrams. So you could have just done this in one step instead of writing 3 plus 12. This is going to be 3 years divided by 3 plus 12, we get 15 years. And that is still going to be times 250 milligrams for the adult dose. So now we do this the same way that we've been doing it. You can do 3 times 250 divided by 15, and we'll end up getting 50 milligrams. Okay, so our answer here is 50 milligrams, and once again, just notice that the years cancel off, and we're left with milligrams as our final answer. Okay, so the next thing is going to be the fifth and final formula. It's going to be calculating dosage per kilogram of body weight. So the difference here from the other ones is that this time we will not be given an adult dose, but instead we're going to be given a suggested pediatric dose. And the dose is going to be measured in milligrams per kilogram per day. This means if we know the child's weight in kilograms, we can find out how many milligrams the child should receive each day. And this method is actually very accurate to use. So here's the formula. We have the child's dose is going to equal the child's weight in kilograms times the pediatric dose, which is in milligrams per kilograms per day. And it's going to be divided by the number of times per day the medication is given. And some observations from this formula. If we're given the weight in pounds, we have to convert this to kilograms. And we have to remember the conversion is 1 kilogram equals 2.2 pounds approximately. And we have to remember to round these dosages our answer to the nearest tenth. And the pediatric dose will be given. So this part of the formula right here, that will be given to us in the question. And the number of times per day the medication is given which is the denominator, that will also be given to us. And it is found in the abbreviation. So if you remember the abbreviations we've seen before, we have BID, the BID, that means twice per day. So the number we would be using is 2 for the denominator. If we see TID, that means 3 times per day. So we'd be using 3 in the denominator. QID is 4 times per day. And Q12H, so remember QH is every hour. So if you have Q12H, it's every 12 hours. So it's a little bit more confusing for these ones because every 12 hours, we have to think about how many times per day that is. That is 2 times per day. Q8H is every 8 hours, which is 3 times per day. The way that you can get these, if it didn't just come to you naturally, is you do the 24 hours divided by 8 hours, which would give you 3, so 3 times per day. And then Q6H is 4 times per day, Q4H is 6 times per day. Okay, so those are the numbers 2, 3, 4, 2, 3, 4, 6, the most commonly used ones that will be the denominator of the formula here. Okay, so let's do a couple examples. For the first example, the physician orders Kefsol into the muscle every 12 hours, and the label is going to read a pediatric dosage 25 milligrams per kilogram per day. We want to know how much Kefsol should a child weighing 5 kilograms receive. So let's just start by writing down the formula. So we have the child's weight in kilograms times the pediatric dose divided by the number of times per day the medication is given. So looking up at the givens that we have up here, we have the child is 5 kilograms, so it's already in kilograms, so we don't need to do any conversion here. And the pediatric dose, which is given 25 milligrams per kilograms per day. And the last thing that we need is the number of times per day the medication is given. So that's going to be every 12 hours. So we have to think if it's every 12 hours, how many times per day that is, which is twice per day. So let's go ahead and plug all of that in here. So we have 5 kilograms times 25 milligrams per kilograms per day divided by 2 times per day. So what happens here with the units is the kilograms are going to cancel. Kilograms divided by kilograms in the numerator. I know that the milligrams per kilograms per day looks a little bit confusing. What actually happens with this one up here is that is equivalent to milligrams. Oops, that's going to be down here actually. It's going to be milligrams per kilograms times the day. And then in the denominator it would end up being 2 per every day. So if you rearrange this using the keep change flip for dividing fractions, you would see that the days would end up canceling. It just looks a lot more confusing the way it's set up. You don't have to worry about that too much. Just long story short, just know that these days will end up canceling. And you can see right now that we're going to be left with the milligrams, and that's it. So you can multiply 5 times 25 and then divide that by 2. That gives us 125 divided by 2, which gives us 62.5 milligrams. So just to kind of have some more with our answer here, we have 62.5 milligrams every 12 hours. Okay, so let's do another example. We have an order of Ancef, and it's going to be into the muscle every 4 hours. So the QID is every 4 hours, and the pediatric dosage is going to be 50 milligrams per kilograms per day. We want to know how much Ancef should a child weighing 30 pounds receive. Okay, so writing down the formula, we have the child's weight times the pediatric dose divided by the number of times per day it's given. So let's take a look at what we're given here. We have QID, so at 4 times per day. So if it's 4 times per day, that's going to mean our denominator is 4. And then we're also given our pediatric dosage, 50 milligrams per kilograms per day. And lastly, we have our weight of 30 pounds. We need to convert that to kilograms. So converting this to kilograms, what we would have to do is either set up a proportion or use dimensional analysis. So using dimensional analysis here, I did 30 pounds times the conversion of 1 kilogram divided by 2.2 pounds. The pounds cancel, we get 30 divided by 2.2. We get 13.63 repeating kilograms. So let's plug everything into the formula, and then I'll mention this 13.63 repeating in a second. So we have everything plugged in here. We notice that the kilograms are going to cancel. The per days cancel. So when we're typing in that 13.63 repeating value into the calculator, what you could do to get around that is instead of using 13.63 repeating, you could just use the value from the conversion, which was up here. You can just use 30 divided by 2.2 and put it in parentheses. The other way you can do this is that when you divide 30 divided by 2.2 and you get the 13.63 repeating, keep that number on the in your calculator, don't clear it, and then you can just multiply that by 50 and then divide it by 4. So those are two ways to kind of get around that repeating number. And to calculate this, you multiply the numerator and then divide by 4, and we end up getting 170.5 milligrams 4 times per day. Okay, let's do one more here. We have an order of Peltro Po every 8 hours. So remember, Po is by mouth or orally. So the medication is going to be orally every 8 hours, and the pediatric dosage is 6 milligrams per kilogram per day. We want to know how much should a child weighing 42 kilograms receive. So writing down the formula. We have the child's weight in kilograms. It's already in kilograms, so we don't have to convert like we did in the last one. We have the pediatric dosage, which is 6 milligrams per kilogram per day. And then we have every 8 hours for the number of times per day it's given. So every 8 hours, we have to think, how many times per day is every 8 hours? That's going to be 3 times per day. And remember, if you can't just think of that off the top of your head, hopefully we can, but if you can't, you would divide 24 hours in a day divided by the 8 hours, that would give you 3. Okay, so plugging all of these values in, we have 42 kilograms times 6 milligrams per kilograms per day divided by 3 times per day. The kilograms will cancel, the days will cancel, and when you multiply the numerator, 42 times 6, and then divide by 3, we end up getting 84, so that's 84 milligrams to be given every 8 hours. Okay, so that is it for this chapter.